Well, hello again. Welcome to another Learning Together session sponsored by the Brosis Foundation. As we have been doing all along, we're just preparing lessons that could help you in your quest to master your math skills. Today, I will introduce you to a new concept that involves factorials, permutations, and combinations. We might not get to combinations today, but we'll see how far we get. We'll start with factorials. One of the things I tell my students is that I take pride in tricking my students. I love to try and trick them. And I do that. I do get through often. I do trick them. But I recommend that you be very careful when you watch me because I always try different tricks. For example, if I ask you, how do you read this? You say, oh, yes. You'd say, yes. And if I ask you, how do you read this? The English teacher would say that you'd have to emphasize. You can't just calmly say yes. You'd have to say something like, yes, with some enthusiasm, with some excitement. So then if I ask you, how do you read this? You would say 6. But then if I ask you, how do you read this? I wonder what you would say. This is yes, but this is yes with emphasis. This is 6. So how would you say this? Well, the truth is, in math world, this has significance. This has relevance. And this is what I'm going to be doing today. This is called 6 factorial. That's how you read it. Not 6, but 6 factorial. Okay? So, what does it mean? So we'll spend a little time focusing on factorials to start. N factorial, where n is any number whatsoever. It could be 5, it could be 3, it could be 10, it could be 100. N factorial is equal to n times n minus 1 times n minus 2. Keep going down until you come to times 1. Where 0 factorial is equal to 1. So that's a definition. Example. 4 factorial is equal to 4 times 3 times 2 times 1. And that equals to 4 3 is 12, 2 times 12, 24. So 4 factorial is 24. 4, so you keep decreasing by 1 until you get to 1. 4 times 3 times 2 times 1. That is 4 factorial. So if I ask you what is 6 factorial, well, it's equal to 6 times 5 times 4 times 3 times 2 times 1. And what is that equal to? Well, this is 4 3 is 12, 2 12 is 24, and this is 30. So then that's 0, 3 4 is 12, and 3 2 6 and 1. I'm getting 720. That's what I get. 6 times 5, 30. 4 times 30 is 120. 6 times 120, yes, 720 is correct. So do you get the idea? So what will happen is, as any good math teacher would do is, now that you have the definition of factorial, how could you use factorial in different ways. How could you do arithmetic with factorial? So let's look at some situations. If I ask you, simplify five factorial over 3 factorial. Yeah, I could do something like that. What is 5 factorial divided by 3 factorial? Then you say, okay, it's equal to 5 times 4 times 3 times 2 times 1 over 3 factorial is 3 times 2 times 1. So when you look at this, you realize, wait a minute, this cancels this cancels this, and of course 1 cancels 1. So what are we left with? 5 times 4 is 20. So then let's go another one. Suppose I ask you what is 10 factorial divided by 8 factorial. Then you know that's going to be 10 times 9 times 8 times 7 times 6. What do you notice? You notice that the 8 factorial would cancel the last 8 items. So all these will be canceled by this, and you're left with just 10 times 9 equal to 90. So 10 factorial divided by 8 factorial. So instead of finding 10 factorial, get a number, 8 factorial, get a number, and then divide, you could actually cancel the last 8 items because they are duplicated top and bottom. So let's do one without writing out all the detail. Now that you see the pattern, and I say to you all the time that math is a lot about patterns. So once you can make the connections, it's easy to connect the dots, okay? So let's try another one. If I ask you what is, say, 9 factorial divided by 7 factorial times 2 factorial. Wow, that gets ugly very fast. Well, how do we approach that? Well, 9 factorial divided by 7 factorial, the 7 factorial cancels the last 7 items. So we're actually left with 9 times 8 over 2 factorial is just 2 times 1. So now we see 2 times 1 is 2, 8 divided by 2 is 4. So we see the answer is 36. Look complicated, but as you break it apart step by step, you see that it actually makes sense. 9 factorial over 7 factorial is just 9 times 8 that's left on top. 2 factorial is just 2 times 1. 9 times 8 is the same as divided by 2. It's just 9 times 4, which is 36. Let's try something else. Okay, so let's try number 4. If I ask you to find what is 2 times 6 factorial over 4 factorial times 3 factorial. Okay, now we're getting somewhere. So how do we approach this? Well, we could say this is equal to 2 times the 4 factorial cancels the last 4 items here. So we're left with 6 times 5. And then what else are we left with at the bottom? We have the 3 factorial that's left. So that's 3 times 2 times 1. So that gives me 3 times 2 times 1 is 6. 6 into 6 goes once. So 2 times 5 is 10. So this ugly expression here simplifies to just the number 10. Okay? And one last one in this category, and let's see, if we did, for example, 12 factorial over 12 factorial times 8 factorial over 14 factorial. Whoa. Whoa. Well, yeah, why not? Times 6 factorial. Okay? Let's see what happens. Well, 12 factorial and 14 factorial. So the 12 cancels the last 12 here. So we end up with 8 factorial over 14 times 13 times 6 factorial. Again, 12 factorial cancels the last 12 items. So we're left with 14 and 13 from here. So now we have 8 factorial left on top, and we have the 14 and 13 times the 6 factorial. So now the 6 factorial cancels the last 6 for 8 factorial. So we're just left with 8 times 7 over 14 times 13. And then I see 7 cancels the 14. So we're left with 2. And then 2 and 8, we end up with 4. So the final answer is 4 over 13. So we get the fraction 4 over 13. So from this, it simplifies to just this. Now let's try something a little bit more abstract. Once I give you numbers, it becomes easy. What happens if I give you something with letters? How will that work? So I can erase this right here. So if I ask you to simplify, say, n plus 1 factorial over n factorial. Wow, 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 wow. Look at that. We started dealing with just numbers and everything was fine. Now you're crazy. Instructor now says, plug some letters in there and see what happens. Well, the principle says that anything factorial is obtained by multiplying that number times the one below it, times the one below it, times the one below it. I should point out that we do factorials with positive integers. So you'll never hear me ask you for -5 factorial, except we're doing negative of 5 factorial. Then that's different, but not -5 factorial. That's not meaningful, okay? This is meaningful. This is not, okay? Good. So, now we're ready to roll. Okay, so whatever it is, if I gave you 20 factorial, it's going to be 20 times, take away 1 gives me 19, take away 1 gives me 18, all the way to the end, get 1. So whatever we start with, we keep subtracting 1, subtracting 1, subtracting 1, until we get to the number 1. We keep decreasing all the way down to 1. So, what does the top look like? Well, it's going to be n plus 1 times, when you subtract 1 from this, you end up with n. And when you subtract 1 from this, you end up with n minus 1. Subtract 1, n minus 2. And that takes care of the top. Let's do the bottom. Start with n, subtract 1, n minus 1. Subtract 1, n minus 2. And you keep going that. Don't you see that this here will cancel everything from here to the end? And what you have left over is n plus 1. So that would be the answer for this. Okay? Suppose, on the same breath, if I ask you what is n plus 2 factorial divided by n factorial. Well, what will it be? It starts with n plus 2, then n plus 1. Notice you subtract 1, you get n plus 1. Then the next one is n. The next one is n minus 1. All the way down to 1. And then for the bottom, we have n factorial. It's going to be n times n minus 1 times n minus 2. This cancels everything from here to the right. And what are you left with? You're left with n plus 2 times n plus 1. And we are experts at expanding that. We know that the answer is going to be n squared plus 3n plus 2. So that will be the answer for this situation here. So we have done questions with integers, and we have done factorials, 2 of them that deal with more abstract, dealing with letters also. And that's it. Nothing deep, but that's what that is. So application, when would we ever have something like this? Let's look at this example. How many 5-digit numbers So here is, how many 5-digit numbers can you form using the digits 1, 2, 3, 4, 5? A, without repetition. B, with repetition. Well, if we're doing the first one, without we have 5 positions. 1, 2, 3, 4, 5. How many choices do we have for the first spot? There are 5 to choose from, so any one of the 5 can be used. So now that we have used one of them, we now only have 4 left. So the second spot has 4 choices. Now that we have used 2, we have 3 left. Now that we have used 3, we have 2 left. Now that we have used 4, there's only 1 left for this position here. So the first spot can be selected 5 ways, 4 ways, 3 ways, 2 ways, 1 way, for a total of 5 times 4 times 3 5 4 is 20, 6 times 20 equal to 120. And your calculator, this is 5 factorial. Your calculator has a button that is factorial. It's usually in the key where you see PRB for probability. That's where you will find factorials, permutations, combinations under the section of probability on your calculator. In other words, if I ask you for 9 factorial, you don't have to go 9 times 8 times 7 times 6. You could just take your calculator, turn it on, and go 9 PRB and you end up with 362 880. See, just by using the calculator, there it is. And if you want to go and multiply 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, I guarantee you, you end up with 362,880. So if you had a question like this is what you could use. So, with repetition, again, we have 5 boxes. This one says that you can repeat your digits. So for the first spot, we have 5 choices. For the second spot, how many choices do we have? Well, it says with repetition, so whatever number you used here, you can still use it again. So you now have 5 spots again, 5 spots again, 5 spots again, 5 spots again. That's what you get if you are allowed to repeat digits. What's the total that you'll get? In this case, it's going to be 5 times 5 times 5 times 5, which is 5 to the power of 5. And I am not going to multiply that out in my head. I am going to take the calculator and do 5 caret 5, and I end up with 3,125. 5 to the 5th power is 3,125. Okay? So there it is. And of course, we know that 5 to the 5th is 25 times 25 times 5. Same answer. Okay? So there it is. This is one way that you could do that. All right? Good. Now, let's talk about permutation. Let's talk about permutation. Permutation is the way that you could select from a list in such a manner that the order is important. For example, if you had a race and there were 8 runners, if if you have 8 runners and you're interested in who come first, second, and third. In other words, you have 8 people and you want to see how many different ways could you get first, second, and third out of these 8, assuming that they all had the same chance of winning. The way that you do that, because first, second, and third is different from third, second, and first. That order is different than this order. Okay? So first, second, and third is very important that you understand that the order is important. Who comes first is different from who comes third. It's a different deal. You know that in the Olympics, if you come first, you get a prize. That's different from if you come second, which is different from if you come third. So the order matters. So that's what you do. You use permutations to select from a list so that the order is important. Okay? I'll give you an example. Suppose you were told that for your debit card, you could use the PIN number, a 4-digit PIN from so you have 5 choices. Let's put another one. You have 6 digits, only those 6 digits that you can use, and you're told that you must create a 4-digit PIN number, 4-digit. So please understand that if it's a PIN number, then the order matters. The order matters. Now, suppose you were told that you cannot repeat. You cannot repeat. Then what you're looking for is how to select 4 from this in such a manner that the order is important. Again, the way that we'll note it is 6 items taken 4 at a time so that the order matters. And now I'm going to explain to you how permutation works. First, I'll give you the definition, and then we'll do some examples. Again, these are the number of ways of selecting a portion from a larger group in such a way that the order matters. Okay? So for example, and so the definition. So this is a literal definition. This is a mathematical definition. So this is n items, NPR. So the n is a superscript, the r is a subscript. So NPR. It means n items chosen r at a time. How do we do this? So this is n factorial over n minus r factorial. That is the definition. So you see, that's why I did factorials first. So now NPR is n factorial over n minus r factorial. And now we need to do examples for this to make sense. Okay? example. How many ways can you So in this case, if you're talking about how they finish, the order is important. First, second, third. So it is, so the solution is going to be 8P3. So it's 8 items, 8 runners, but we want to find out how we can arrange the 3 top finishers. Okay? So how many ways can we do that? It's going to be 8 factorial over 8 minus 3 factorial. So that's equal to 8 factorial over 8 minus 3 is 5 factorial. So remember we talked about how to simplify factorials. This 5 factorial cancels the last 5. So therefore it's 8 times 7 times 6. Which is equal to 8 sevens 56 and 56 times 6. So that is 336. 8 sevens 56, 6 sixes 30, 6 6 5 30, and 333, 336. Okay, so we're saying that you have 8 runners and there are 336 ways that you could end up with first, second, and third. Assuming that anybody could finish first, anybody could finish second, and anybody could finish third. Okay? Let's try another one. How many ways can you arrange? How many ways can you arrange 10 different books on a shelf? So if the math book is first, it's going to be a different arrangement than if the math book is last. Notice the word arrange. So the order is important. Once you hear the word arrange, order is important. Okay? So you have 10 books and you're trying to arrange all 10. So guess what? It's going to be 10p 10. You're trying to arrange all 10. You're not taking a fraction, you're taking all of them. And you want to set them up in a certain order. So is the math book in the beginning, in the middle, or at the end? It's a different arrangement, okay? It's like, for example, if you have a playlist and you have 10 songs, how many ways could you arrange the way the order in which the songs are played? Get it? So the order is important. When you hear the word arrange, order, sequencing is important. Okay, so this is going to be 10 factorial over 10 minus 10 factorial. So it's 10 factorial over 10 minus 10 is 0 factorial. And we discussed in the definition earlier on of factorial that 0 factorial is 1. So it's really 10 factorial over 1. And I am not going to do 10 times 9 times da 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 da. I'm going to take my calculator. I'm going to type in 10 PRB, and I'm going to go to factorial, press enter. So now I have 10 factorial, and I press enter, and I get this massive number, 362,800, sorry, 3,628,800. 3,682,800. Let me double check to make sure that I typed it in correct. 10 PRB factorial, and gives me 362. No, 362. 362,000. 3,628,800. That is the answer. Okay? So that's what this is all about. Okay? So here is an example of something that you might want to consider. The top 10 finishers in a marathon if there are 25 runners, how many ways here it is. So there's a marathon and there are 25 contestants. And if 10 of them are going to get prizes and they ask you, how many ways could we select 10 out of the 25? So that the order is important. Notice the order is important. Okay? Well, based on what we have discussed today, you know that the answer is going to be 25P10. 25P10. And that, of course, is going to be equal to 25 factorial over 25 minus 10 factorial. That's going to be equal to 25 factorial over 15 factorial. And so therefore, it's going to be equal to 25 times 24 times 23 all the way down to times 16. Okay? So instead of me trying to do that in my head, I can take my calculator and I can say 25 factorial and I get a massive number. And I'm going to say divided by 15 factorial and I end up with a large number. How many digits right here? Okay, it's to the 10, it's 1.186167629 times 10 to the power 13. So that's a massive number. So it's over, it's a trillion. So it's 1.186 trillion. It's a large number. Okay? But that's how we use factorials to calculate, to determine a number of ways of making these arrangements. So now I would like to introduce you to combinations. Now, this week or this session, we're going to focus on the definitions. And next session, part B, this is part A. Part B, I'm going to use different questions to see if we could determine whether to use permutation, combination, or just straight factorial, or just straight multiplication principle. So that's what we're going to do next class, next session, to try and apply these three principles along with the multiplication principle. So, combinations. So combinations are very similar to permutations, except so this is a big deal right here. So when you do combinations, the order is not important. The order is not important. With permutations, the order is important. What is first makes a difference. With combinations, the order doesn't matter. It doesn't matter how you finish. It doesn't matter how you're selected, as long as you're in the selected group. It's the same group. The order is not important. And you might ask, so when will that be an example? Well, I'll give you an example. Suppose we're part of a team. Say, for example, we play soccer, and the soccer squad has 24 players, 24. And you decide that we're going to plan a party for the end of the season, and you want 5 members of the team to be a part of that committee to plan for the party. So again, 24 people, you want to select 5 to plan for the party. Does it matter who is first? Does it matter who is second? No. As long as you're in that 5, you are on the committee. Let's use another example. Suppose I was rich and I say to my class, listen, I have 40 students and I'm going to sponsor 6 of you to go to Jamaica for a beautiful vacation, all expense paid. Do you care if you are number 1, number 2, number 3, number 4, number 5, or number 6? Does it matter? No. As long as you're one of the 6, you're going to be enjoying that vacation with the other 5 people. So that is the situation where the order does not matter. It's when you're selecting a group from a group such that the order is not important. And especially if there is no position assigned to each member of the subset that is selected. Use another example. If we had 24 players on the soccer team, soccer squad, and we're selecting a group of 3 people to plan for this celebration. But you want 1 person to be the chairperson, 1 to be the treasurer, and 1 to be the secretary. Now you're giving positions to the selected people So therefore now it matters who is the chairperson, who is the secretary, and who is the treasurer. So then you would have to use permutation because there are positions assigned to each person, or there are titles assigned to each person. So those are the little situations that we have to keep in mind so we can have clarity. So what is the mathematical definition? Again, combinations represent the number of ways of selecting R items from a total of N items so that the order is not important. So the mathematical definition is NCR. NCR, N superscript, R subscript, is equal to N factorial over N minus R factorial times R factorial. So it's very similar to what we did for permutations, but now we have the R factorial on the bottom as well. So this is a step up. Okay, you are now dividing by R factorial in addition to the N minus R. So that's why the number of combinations will always be smaller than the number of permutations, because you're further dividing by another number. Okay, so example. How many selecting 5 people a group of 15 if the order does not matter. So right away we know that it's combination. Once you see order does not matter, it's combination. So it's 15 C 5. 15 people taken 5 at a time. So it's going to be equal to 15 factorial over 15 minus 5 factorial times 5 factorial. So it's going to be equal to 15 factorial over 10 factorial 5 factorial. So the 10 factorial cancels the last 10. So now we end up with 15 times 14 times 13 times 12 times 11 over 5 factorial, because the 10 cancels the last 10. So it's 5 times 4 times 3 times 2 times 1. And as a kid growing up, I was so poor I couldn't afford a calculator. So I'm able to do this using my head. I say, oh, okay, 5 times 3 is 15, so that cancels this. These 2 cancels that. So now 4 into 12 goes 3 times. 2 into 14 goes 7. So now it's 7 times 13 times 3 times 11. So what is 7 times 13? 7 3 is 21, 7 1 is 91. And what is 3 times 11 is 33. So 3, 27, 0, 3, 27. So it is 3, 0, 0, 3. So I'm getting 3, 0, 0, 3. Let me quickly double check to make sure I'm correct. So 15 and 3, yes. 4, yes. 2, 7. So 7 times 13 is 91. 3 times 11, 33. 3 1s 3, 3 9s 27, 0. 3 1s 3, 3 9s 27, 3003. 3003, final answer, yes. There it is. How cool is that? If we're doing permutation, then we would not be dividing by this 5 times 4 times 3 times 2 times 1. You would not have that part. Okay, let's try another one. Okay, how many players are on a volleyball team? Let's say 6. 6 players. Okay, and suppose the squad has 12 people. So to start, how many starters can you have? How many ways do you have to select 6 players out of your group of 12? Well, for volleyball, nobody has a position because there's a rotation. So everybody gets to play every position. That's how volleyball is. So we're going to say that everybody has an equal opportunity. So you have 12 volleyball and then 6 starters. So how many ways can I select my 6 starters? So the answer is 12C6 because the order is not important. So 12C6 gives me 12 factorial over 12 minus 6 factorial times 6 factorial. So that gives me 12 times 11 times 10 times 9 times 8 times 7. Because this is 6 factorial. It cancels the last 6. And then I also have an additional 6 factorial. So it's 6 times 5. Again, I showed you that you could say, okay, 2, well, what do you want to do? Let's go 2 times 6 is 12. 4 goes into 8 2 times. 5 goes into 10 2 times. 3 goes into 9 3 times. So now we have 11 times 2 times 3 times 2 times 7. So 2, 3, 6, 6 times 11, 66. 2, 3, 6, and then 2 times 7, 14. So now we have 66 times 14. 4, 6 is 24. So now we end up with 924. So we have 924 ways to get our 6 players, assuming that all of them are equally qualified. Okay? Beautiful. Okay. Now to finish off, I just want to bring in what is called the multiplication principle. Okay, Mark goes on vacation with 4 pairs of jeans, it's a beach vacation, by the way, 8 t-shirts, 2 pairs of sneakers and 3 pairs of sandals. How many outfits? How many possible outfits involving jeans, t-shirt, and footwear? Okay. How many possible outfits can you create? Well, we have 3 groups. For jeans, for t-shirt, and for footwear. So how many pairs of jeans? We have 4 choices. How many t-shirts? We have 8 choices. How many different types of footwear do we have? We have 2 sneakers and 3 sandals. So you have 5 to choose from. So you can select 4 different pairs of jeans to choose from. You can use this one, that one, that one, or that one. T-shirts, you have 8 to choose from. Footwear, you have 5 choices. So the multiplication principle says that if you have n ways of doing one thing followed by p ways of doing another thing, the number of ways of doing the first followed by the second is n times p. Just multiply the numbers, and that will give you the total number of ways that you could do both of them. Okay? So in this case, the answer is 4 times 8 times 5, and that gives us 5 4 is 20, 8 times 20, 160. So Mark could create 160 different outfits by changing up his arrangement. Okay? So that's what that's about. I'll use one more example as we close. One more example. Okay. Okay, Mary wants to create a secret code involving one letter and a single digit number. How many codes could she create? So she comes up with this great idea that I'm going to have a secret code for my friends that's going to have one letter, one number, and the number is 1 digit only. Okay? How many different codes could she create? Well, so we're going to need 2 things. A number, a letter, and a number. So how many letters do we have? I think we have 26 letters in the alphabet. How many numbers do we have to choose from? How many single-digit numbers do we have to choose from? I think we have 10. So if you can do the number of letters 26 ways, the number of, we usually use A for letters anyway, and the number of single-digit numbers 10, so the total is 10 times 26 equals to 260. So there are 260 codes that she could create. All right? So now this is giving you an idea. Sometimes you will do permutation, sometimes you will do combinations, sometimes you just do straight multiplication principle. Okay? So the next session, we're going to be doing random questions and see how we could tackle them based on the information given in each question. We'll decide which way to go, because many times they will not tell you that you must use permutation, or you must use combination, or you must use the multiplication principle. It is for you to read and discern which approach to take. And it's all in the language used in the problem described. Okay? So we are prepped, we are prepared. Next time we come together, we'll cook. We'll put it all together and see if it makes sense. Okay? Thank you so much for joining us. Learning Together, sponsored by Brosis Foundation. I do hope that this triggered something in your mind and stimulate your thinking process. We look forward to having you join us for future presentations. Enjoy the rest of your day. Thank you.